Hello everyone, welcome to the new chapter. In this chapter, I'm going to talk about Spark stream processing. So far, we have seen Spark batch processing. We have also seen how Kafka helps in ingesting stream data using Kafka brokers and topics. Now, we'll complete this entire streaming layer by talking about Spark streaming and integrating Spark with Kafka. And I have divided this chapter into small portions, or you can say subsections. This is the agenda of the first section, wherein I'll give you introduction of structured streaming and the stream processing model in Spark. We'll talk about triggers and output modes at a high level because I'll come back to these topics later on again. Finally, we'll see how the implementation would be done using PySpark. First of all, streaming ingestion, and you already know what streaming ingestion is. We ingest data from streaming sources. The streaming sources can be real-time applications, IoT devices, database changes like CDC or change data capture, wherein all the modifications in the databases, any updates, insert, deletes are captured and can be sent to a Kafka topic, and from there it can be read. So these are the various use cases that you can come across in streaming ingestion: stock market analysis, financial fraud detection, predictive maintenance, autonomous cars, traffic management, network monitoring, the application log monitoring, predictive maintenance, etc. These are the typical and normal streaming ingestion use cases. Of course, there can be a lot of other use cases that you can come across. In streaming ingestion, data is ingested in Kafka from real-time applications. We get the data into Kafka, and from there we use Spark streaming to process the data using the streaming APIs, transformations, actions that we have in Spark. Now, how this Spark structured streaming works. We have seen batch processing, wherein we have data in files in various file formats like CSV, JSON, Parquet, Avro. It can be from database sources like Postgres, MySQL using JDBC driver. It can be from data warehouse sources like Redshift. You can use Snowflake also, NoSQL database also. And that's where the processing was in batch. And we had used data frame API and Spark SQL to do the processing. One good news is that if you use Spark structured streaming, the transformation would be done using the same data frame API and using the same Spark SQL that we know. For structured streaming, we do not need any different transformation or any different aggregation APIs. There are a few things like windowing, which is not window functions, event time processing, watermarking, etc., which are a little different. But as far as transformations and aggregations are concerned, you'll be using the same data frame APIs and Spark SQL that we have talked about in the course. Because Spark started with batch processing, the structured streaming model of Spark handles the data processing using micro batches. So let me see what do I mean by that. Let's say this is the Kafka topic and we have a real-time application. It can be any application which is sending data to Kafka. Whenever the application generates data, that data is sent to Kafka and it continues generating the data, and the data would be sent to Kafka one after the other. Now, let's say the real-time application has sent this 7 blocks of data. Let's say, for example, you consider this 7 blocks of data as a small batch. Even though they are coming one after the other, even though they are coming in a streaming fashion, but to process that in Spark, we consider all these messages together as a micro batch. So we can call this as micro batch 1. And then we have the Spark processing. The Spark structured streaming model will take the data from this micro batch 1, do the transformation and the processing, and generate the output. So this is the first output. Then let's say another set of micro batch or another set of data that has come into the Kafka topic. It would be considered as micro batch 2, which would again go to the Spark processing layer, and a new output would be generated. So this is how the Spark structured streaming model works. The processing happens at micro batch level. What should be the micro batch? Should it be number of seconds? Should it be number of messages, etc.? That can be handled by us. It can be milliseconds also, by the way. It's not that it has to be in seconds only. So the processing can happen, let's say, after a certain milliseconds, or maybe after 5 seconds, 10 seconds, etc. So that's what a micro batch is. Now, the structured stream processing, or the structured stream data, or the streaming data that you get in a streaming ingestion layer like Kafka, is divided into these smaller batches, and then we can use Spark to do just like you have done, or just like you have used Spark in batch processing. But instead of a full-fledged batch, we'll be using a micro batch here. And it helps in incremental data processing also, because let's say we process the initial micro batch, then we get a new micro batch. We can consider the new micro batch as an incremental data. And there are two concepts that you have to remember in the context of structured streaming. We'll come back to this later on, but I just wanted to introduce you to these two time. One is the event time. Event time is when the data is generated. So the event time would be attached to the message or to the record by the real-time application or the IoT application, whatever application is sending the stream data. That's what event time is, meaning when the data is generated, and the event time would be associated with the data by the application itself. Then you have processing time, and processing time is the time when data is processed, meaning when Spark actually processes the data. That's what the processing time is. And we can use this processing time to define the micro batch interval. A little bit more in the stream processing model, because it is not batch processing, the sources and the targets are a little different in the stream processing model. And in structured streaming, we call it as stream sources and stream sinks. Instead of source and target, we call it as source and sink. And there are only a number of sources that are supported. For example, Kafka is of course one of the sources. Then there's file source also. Now you can think how we can use file source as stream processing. We'll talk about it later on, but we can use file source also in the stream processing model. And this modification actually came in when Kappa architecture was introduced. We'll talk about Kappa architecture later on, but we can use file source also in the stream processing model. Then you have socket source like TCP socket. I'll not be showing you socket source at all. This is mainly used for testing. We'll do all the hands-on and development using Kafka and file source only. In AWS, there is AWS Kinesis, which is similar to Kafka, but it is native to AWS. AWS Kinesis is used to ingest real-time data. Right, so these are the various sources, and these are called as data sources. Spark stream processing can read data from here and then do the processing. Because we have data sources, we can have data sinks also. And we can have Kafka sync and file sync, just like Kafka source and file source. Why do we have Kafka sync? File sync might make sense because maybe after processing, you want to send the data or store the data in a file. Why do you have Kafka sync? Because it might be the case that we want to process the data and send it to another Kafka topic, which will be used by another Spark streaming or another consumer. Here in this case, Spark would be the consumer of the Kafka topic. Then you have console sync, in which case the output would be displayed in the console. So in our case, we'll use the terminal or the command line interface to see the output. Then you have memory sync, wherein the output is stored to a temporary table in memory. I will not show you memory sync. You can try it out yourself. Memory sync is mainly used for testing. And if you are doing testing, it's better to test in console sync. And there are traditional syncs like databases and data warehouse systems. So these are the syncs. We have Kafka, file, database, and data warehouse. After the processing is done, Spark would write the data in these syncs. There are two other syncs like for each sync and for each batch sync. It is similar to for each and for each partition API that I had used earlier. I'm not sure why these are called as syncs. These are mainly should be considered in the processing layer. So you get the rows, you apply some function on those individual rows or for an individual micro batch, and then send the data to either Kafka sync, file sync, or database sync, or data warehouse sync. So this is the stream processing model as far as source and sinks are concerned. In the previous diagram, I had shown you that we get the data from various sources, we do the processing, and then put the data or put the processed data in various sinks. Now the question is, how do you do the processing? You would be happy to know that the transformations and aggregations that are used in stream processing is exactly same as that of batch. So we do not have to learn the various transformations and aggregations. We'll be using the same transformations, aggregations, actions, etc. that you have learned in the Spark batch processing. But there are some additional APIs. I'll be introducing you to the most basic APIs now. Then we'll go to event time processing later on, wherein I will talk about other APIs. Now in this case, the first API that you use to read data from source is the read stream API. Instead of spark.read, we'll be using spark read stream. To write the data, we'll be using spark write stream. So df, the data frame name, followed by write stream instead of the write API. Okay, so architecturally, how all these things fit together? We have seen Spark cluster, we have seen Kafka cluster, we have the stream processing model, etc. So how to fit all of them together? So let's say this is the Spark cluster, which is either running on EMR or maybe on a local machine in a standalone mode. If you are using EMR, then Spark would run in cluster mode. Then we have Kafka cluster. We can start a Kafka cluster on a local machine, or we can use AWS MSK also, that you have seen earlier. So we'll be creating multiple topics in the Kafka cluster, which is separate than the EMR cluster. Of course, they have to be in the same VPC, can be in different AZs, but have to be in same VPC for sure. You can have different VPC also, but things would be much more complicated in that case. Now, after this, what we do, we use this Spark streaming code or Spark streaming application. If you want to run it on the EMR cluster, we upload the code in S3. Then we can use the PySpark submit from the EMR's primary node, or we can use AWS CLI from our local laptop to submit the code in EMR using EMR steps. Any which ways, we'll be submitting the Spark application to the EMR cluster. The moment we submit the application, a driver would be spawned or a driver would be started, which would talk to the resource manager, etc. And then the executors would be started. And this is for the stream application. But there would be an additional job which would be started whenever we start the stream application in either the cluster, EMR cluster, or local laptop. So that would be a background job. And this background job would run as a daemon, meaning that this background job would run continuously. The purpose of this background job is to get the data from the Kafka topic. And this is the Spark application or Spark stream application, which is a little different than batch application. In case of batch application, we do not have any background job, but for streaming application, we'll be having a background job which will continuously run, or which will run in a daemon mode till the time we do not stop the stream application. And the purpose of this background job is to pull the records from these topics. We can read from one or more topic also. And then, as usual, Spark will do the processing and it would write the data either to S3 or database or data warehouse, or can be to another Kafka topic also. So it can be any of the things that I have shown you in the previous slide. So this is the streaming architecture. Nothing changes. We submit the Spark streaming application, and the moment we submit the Spark streaming application, an additional component would be started, which would be a background job. And the purpose of this background job is to read data from Kafka topic whenever the records or messages are available in that topic. By now, you might have understood that the stream processing model is different than the batch processing model. In batch processing model, we submit the Spark application. The Spark application would read from either file sources or database sources or data warehouse, do the processing and write the records to any of the targets, and then it will stop. But stream processing is not like that, because the stream application would keep on running 24/7 unless the application fails or you stop the application manually, because streaming data would also come continuously. That is the purpose of streaming application, and that is the purpose of stream processing, that the data gets generated continuously and the data is ingested continuously in streaming fashion. So the data has to be processed continuously also. But at the same time, I had also shown you that Spark uses micro batches. In earlier slides, I had shown you that whenever there are a set of messages or after a certain time, Spark will do the processing. It is not that Spark will read the records one by one and then do the processing. There's a separate model for this, which is continuous processing, that I'll talk in later videos. But as of now, we have this concept of micro batches. The question is when those micro batches should be executed, when those transformations should be executed. The frequency or the interval of those micro batches are controlled by something called trigger. And there are various types of triggers. First of all, there is no trigger. If you do not mention any trigger, Spark would process the data as long as it is available in the topic. I'll show you how this no trigger option works. Then you have fixed interval, and we can mention a fixed interval using something called processing time. I told you about the processing time, which is nothing but the time at which Spark would process the data. So that's what processing time is, and we'll be using the processing time concept to execute the streaming application at fixed intervals. Then you have available now trigger. At a high level, the purpose of available now trigger is to process all the available records in an incremental fashion. So that's what incremental processing is. We can mention the batch size also for the incremental records. That's what available now trigger is. Then you have continuous processing, and it is not in production yet. It has been in experimental mode from the version 2.3. We are at Spark 4 now at the time of this recording. Still it is in experimental mode. I have been showing you Spark 3.5.5, but Spark 4 has been released. The reason I'm using 3.5.5 because as a best practice you should use N-1 version. Anyway, we'll look at continuous processing mode also later on. So let's say we have this Kafka topic from where we are reading the data or we are reading the records. We use this read stream API to read the records from Kafka topic. It can be Kafka topic, it can be Kinesis data streams, any streaming ingestion framework or technology, but would be using read stream only. This is the only API which is available for stream processing. After that, we'll use all the transformations and actions to process the data or to transform the data, and then we use the write stream API to write the record in one of the sinks that we have discussed. If we are using no trigger, then we do not have to mention anything along with write stream API. But if you are using fixed interval, we'll have to provide the processing time using this trigger option, dot trigger, and in brackets we'll have to mention processing time. In this case, I'm using 2 seconds, meaning that whatever record has been accumulated in Kafka topic for the last 2 seconds, Spark will process those records. And after processing the records, it has to store the records in one of the sinks. It can be a JDBC sink, it can be a file sink, it can be another Kafka sink, it can be console sink, etc. As I said earlier, the stream processing model is very different than batch processing. So that's why the output mode of stream processing is also different. There are 3 output modes which are available in stream processing, which is very different than batch processing. The first one is the append mode, and this mode is only supported for queries that will never change the rows that have been added to the output. What I mean by that, if you are using append mode, let's say this is the first trigger and it would trigger this processing layer, Spark would do the processing, and then let's say the records are 1A and 2B. These are 2 records, or these are the output which have been generated by the processing layer. Let's say we have another trigger and Spark would start the processing or do the processing and then generate the output, and then it would write the output. Now you see the output records are very different from the first output set. In the first output we had 1A, 2B. In the second output we had 3C and 4D. So 1A and 2B have not been added or have not been changed. Append mode is supported only for these type of output. Of course, we'll go into the details of append mode later on. In this video, I'm just introducing you to all the output modes that are available. Then you have complete mode, wherein the entire result set is the output after every trigger. So this is, let's say, the complete mode. We have trigger number 1, we do the processing, and then we put the output in output data like this. We have 1A, 2B and 3C. Then we have another trigger which would process the data using Spark, and the entire output would be replaced. The new output would be 1D, 4E, 5F. It does not matter what was there in the previous output. Spark would disregard that because that is the purpose of complete mode. Finally, we have update mode. It is used only in those scenarios where the rows that have been changed since the last trigger would be outputted. What I mean by that, this is the output mode. This is the first trigger. We have 1A, 2B and 3C. Let's say we get another trigger and do the processing. But in this case, having new records or along with new records, we have modified 2B and 3C. So in this update mode, the output result set would contain only 2 and 3. So the value of 2 has been changed to E and the value of 3 has been changed to D. This is the update output mode. So these are the 3 output modes which are available in the stream processing model. We'll go into the detail in future videos, but as I said, I wanted to introduce you so that we can do some hands-on to start with.